Let me share the screen. Okay, 1 second. Here we are. You should see my screen, Fernando. If not, just let me know, okay? And one thing, can you hear me well?
Yes,
I assume yes. And just 1 second, because I'm not sure I can hear you. No, in fact, my audio was closed. So can you please try to say something, Fernando?
I'm able to hear you, sir.
Okay, very good. I can hear you. I'm not using the room of the microphone, the audio of the room. I'm using the audio of my PC, and therefore I will need to repeat what you say if you have any question. Okay, good. So a brief recap of what we did last time. Basically and essentially, we introduced the Linux operating system. And let me just go at the beginning of the slides. This is a file that you can download from my website. Actually, it's here. And the link is the link that is highlighted with my mouse now. So basically, I already explained why we need to resort to Linux, and the explanation is that the computing power is more efficient, is more efficiently used by the operating system, and also the fact that in order to download the data and to refer to information that is available on the web, Linux is more reliable. And in fact, most of the web servers, for instance, run over Linux, and it's using the PC in a more efficient way. I just would like to remind you that we dedicated time in the last lecture to learn how to install the virtual machine, because we basically agreed that in order to quickly run a Linux system on your PC, quickly, I mean without making any radical change to your computer setting, the easiest way is to install the virtual machine. I explained to you that we have two alternatives, VMware and VirtualBox. We used VirtualBox, and if I'm not wrong, we successfully installed, all of you, the Linux operating system on the virtual machine. Also, you were successful, or? Yeah, okay, very good. And let me now start the virtual machine on my PC. So and please also yourself start the virtual machine. And so in my case, I am already working on a Linux system. And therefore, what you see here in terms of turning on VirtualBox is not precisely what you see on your PC. I need to click on VirtualBox as you, but the path is a bit different. And then I have actually two machines on my VirtualBox, a Windows one and a Linux one. The Linux one is the one that I installed last time together with you. I start my virtual machine. And this is what I get. Just 1 second, because it takes some time. Also, please start your virtual machine. Mine is already started. I can put it in full screen view, full screen mode. Okay. And let me just, okay, now I am in full screen. It's not really full in my case. I'm not sure what is the situation in your case. I have the possibility to enlarge it because it's not really full screen. It's a little bit, just 1 second, I give more light to, I need to give more light to my screen because otherwise I can't see it. Just 1 second. Let me just, okay, good. I go back to my virtual machine, 1 second. Here it is. Okay. Now it's lighter. Yeah. Let me just, yeah. Just 1 second. I come to your PC. Just 1 second. I give more light. Okay. Let me see what happens here. Why not switch the other video? Let's see, and I need to switch the video box to see and try to click that button. Document. I think the problem is this changes. Yeah, that's the horse. So what would be the last reflection of the book? I will change it. It doesn't find it. You have to put the previous in it. Sorry, I am here. We are trying to solve a technical problem. Okay, now when you start your virtual Linux, you are required to put the password in. Please put your password in. And then you get to, is it okay? Perfect. You get to the virtual machine, okay? Now, let me go back to the slides, because of course, now we have to start working on this virtual machine. And Linux is very easy to use because it's like Windows. There is no difference. And therefore, you have to expect to click on a button that shows all the available applications. And the button is on the upper left here. This kind of mouse that you see, it's you see here that there is the web browser, the mail reader, the file manager, and the terminal emulator. There are only few applications here, but if you click on all applications, you see that there is a long list like you have in Windows, okay? And there is also a Office suite. There is a writer, an Excel, Calc is an emulator of Excel. These softwares are not fully compatible with Microsoft. To some extent, to Microsoft Office. To some extent, they are. But we are not considering now to fully use the Linux system. We need to use it only for our purposes for now. But I just wanted to show to you that you have a lot of programs here accessible, like in Windows, and some of them work better than Windows. Some of them work in a less satisfactory way, but they are interesting options. And of course, we are not now exploring each application because, as I said, we have a limited time and we need to converge to what we need to do. But I just wanted to tell you that here there is a world to explore. And my suggestion is not to explore it now, just to keep into account that this is indeed an opportunity. And if you use these buttons, so if you use the menus in accessing the programs, it's very similar to Windows, and it's not more complicated. Actually, Linux was conceived to work on the console, not to work under Windows, so not to work with menus, but work on a console. And the reason is that at the start, they wanted to save computational efficiency, which is taken otherwise by the user interface. And in fact, there are some Linux distro that don't have the user interface, only show you the console. I just tell you this because what is the reason why I'm telling this? Not to suggest you to only use the console, but indeed, and your PC is not very performing, a possibility could be to install not this Ubuntu, but a lighter version, which doesn't have user interface. What is the complication? The complication is that it's much easier to work through a user interface. You have menus, you have icons. With a console, you need to know the commands, okay? Because a console, I show you how a console looks like, okay? And for instance, it's very easy. Let me see if it works on the virtual machine. I try to press F1 or Control F1. Maybe it doesn't work here. But anyway, I'll show you later. All of the virtual machine. So anyway, I just wanted to show you, this is how the console looks like. You see that there is, sorry, it is very, very tiny, but you see that there is a cursor flashing. It's waiting for my input, okay? And of course, you need to know the input to give. Let me go back to the virtual machine. And so what is the reason why it was conceived to work with the console? As I said, to save computational efficiency. Actually, there are some uses of Linux that, and some of our uses, which indeed require the use of the console, because there are programs that are prepared to run in a Windowized environment. So there is a program like File Manager. I click on the File Manager, and it works in a window, okay? But there are other programs, and particularly those that we need to use in order to download our data that need the use of the console. So this is why I'm mentioning this to you. So we also need to know how to work with the console. So how can we need quickly how to work with the console? Very quickly, what we need to do is, let me go back to the slides, okay? And to my slides here. What we need to do is to learn some basic commands. My suggestion for you, just 1 second, because this one is keeping calling and I don't understand what. Pronto? Yeah, it's advertisement. Sorry for that. Let me turn the phone off so it's much easier Okay, good. Here on these slides, there are some examples of commands to work with the console. We already discussed some of them, like LL. And my suggestion for you, let's learning by doing, because of course it's an open world. It's very complicated. I don't know all the commands of the console. I learned the commands that I need. So this is also my suggestion for you, but please have a look at these slides because they are not very long, and there is some historical information, and there is also description. Let me go forward. There is a description of some commands. Okay, let me move quickly forward. Okay, because I want to. There are also several informations here that I'm not discussing with you, like how is the file system organized, because, you know, in Windows you have the desktop, here you have the desktop as well, but they are placed in different positions, and I don't think we need to discuss this, but let's move forward. This is the user interface, and this is another one. This is another distro. It's not ours, but doesn't make a big difference. It's another Linux. Here is the command line. Okay. You see what is written here. Text mode. It's a way to control the computer via the keyboard. It's common used on high performance computing. So high performance computing uses the command line. So if you think about Leonardo, doesn't have a user interface. It's a command line. It's somewhat archaic, but very powerful. What I said can be much quicker, and this is interesting for you. Okay, much quicker can be. Implicitly assumes that you know what you are doing. Don't be scared. And if anything goes wrong, Control-C, you can stop the command. There is one nice thing in Linux. First, two nice things. First, it is virus protected. You don't have to bother about viruses. So for instance, sometimes I get scam emails, I mean, with Linux, and you don't have to be concerned because you are on a virtual machine. Even if for some reason you are so smart to get a virus under Linux, even if you succeed, it's a very challenging task because it's almost impossible. But even if you succeed, the virus doesn't, or virus, depends on the American English, doesn't migrate from the virtual machine to your machine. So if something goes wrong with the virtual machine and you get completely stuck, you forget the password, or just remove the virtual machine and start a new one. Of course, it takes some time, but it doesn't affect your home PC at all. So this is a nice thing. For instance, sometimes I would like to make experiments under Linux, like I want to try to run Microsoft Office last version under Linux. I did it last year, but I don't do that directly on my PC because it can get stuck. So I open a virtual machine, try, I failed, okay, let's throw away the virtual machine. And that's it, okay? Second nice thing in Linux is almost impossible to make a big trouble if you don't get administrator. So you are by default administrator in your virtual machine in Linux, but in order to get the administrator right, you have to type a specific command. If you don't do that, and I show you what is the command, if you don't do that, you don't make big trouble. This is why sometimes I give my computer to my son. I say, okay, I don't give you the super user password. This is the PC. You can't make any trouble. In Windows, it's not like that, okay? Okay, I'll tell you because we need to install some software and you need to become super user to install software. I tell you how to do that. So here there are some important rules on the command line. Case sensitive. There is no recycle bin, and but actually there is one for the graphical user interface. You have one recycle bin in your PC. Let's see if by default it is visualized. Just 1 second. I need to deactivate the screen share. By default, yeah, trash, it's here. So there is indeed a recycle bin. It's not by default in Linux, but it's given by the GUI. The GUI is the graphical user interface. And but just one thing, when files are deleted on the command line, they instantly disappear forever. Okay, so if you delete files with the file manager, they go in the recycle bin. If you delete with the command line, they disappear forever. You may think this is stupid. Actually, why is that? Because the trash bin takes a lot of space in the PC. And therefore, in high performance computing, they assume that you are skilled, you don't make a mistake, or if you make a mistake, you have a backup, and you can restore your PC. And therefore, they assume that you don't need an undelete, you don't need a safety policy, okay? And you should always practice new commands on a test system that is not used in a production environment. What I said, virtual machine. Keep in mind one thing. With the virtual machine, I go back to it, but let me go back to VirtualBox. You can take a snapshot. Click on machine, and then there should be here. Maybe that you have to. Let me see where is the snapshot. I think maybe probably it is to be turned off to take the snapshot. And let me see, new add set, clone, move. You can clone it, but only if it is turned off. Export, remove. Just 1 second, because I don't understand where it is, but it's possible to take a snapshot. I think maybe it appears only when, just 1 second, settings. It should be somewhere here. Advanced description. 1 second. Display, recording, storage. Machine. Take a snapshot here, and but you need to turn the machine off. What is the snapshot? It is a clone of your virtual machine, and I suggest you not to make it because it takes the amount of disk space that is taken by the virtual machine. It's a clone, so when you are happy with your virtual machine and you want to make a test, you can clone it, and then you make your test. If something goes wrong, you go back to the previous configuration. This is a nice opportunity, and you can explore it. But actually, we don't strictly need it, okay? So, basically, you don't need a file extension, but this is also the case for Windows today. And it is useful to put an extension, and there is a list of commands. But let's just let you go through it, okay? And I'm only teaching to you the commands that we need. But if you need some more information, these slides are not long, and you see that they are something like 70 pages, but they are very easy to read, and you can use it. Part of these, you see, using the root account. Root means super user. I will tell you how to do it. Okay, let's go to our virtual machine, and let's make something more interesting and fun. And let me open a console. So for opening a console, click on the mouse here, Terminal Emulator. And you get this black window. You can maximize it. Now I increase the font. So preferences. Let me put the font at something like appearance here. Something like, I think this is 10. I put it at 20 because select. Okay, now close. Now I got the fonts enlarged. You can do the same if you want. What I did is edit, preferences, appearance, and then here there is the font and the size of the font. And basically, by clicking on the size of the fonts, I got to the font size 20. Select, close. Okay, now let's install R. Okay, I told you that we will work with R and Python. Okay, Python is already installed. If you, let me check if it is. Python 3 on the console. You see, I am in the Python console. Okay. So we didn't say anything about Python. And let me start with R, because I think it is simpler. So let me quit here. I don't remember what is the command to quit. Let me make some attempt. Okay, it's quit, double parenthesis. So Python is already there. You don't need it. R is not there. So let me just clear the screen, Control L. L. Okay. And now let me install R. First, there are other ways to install commands, to install software in Linux. I'm now explaining how to install a software from the console. Okay. You need to know what is the name of the software to install. And therefore, if you don't know it, what you can do is to open a Google window and say, install command line R Ubuntu or Linux, and you get the command, okay? And I'll tell you later how you can use the menus to install software. Important thing, the software that you install under Linux is free software. There is no freeware, there is no license expiring. What you install from the command line, everything is free. It's open source, okay? So first of all, for installing software, you need to become super user. And then the command is sudo, it means super user do. And then you put a space. Of course, as you can imagine, when I press return, it will have to ask me the password. And keep in mind that what you do under root rights and as a super user is powerful, maybe damaging, okay? So sudo means super user do. Now the command is apt-get. I think get can be left out. There is an alias, but let's use apt-get. apt stays for something like get a software, and the option get is get it. But then we need to say also install. Otherwise, it gets the installer but doesn't run it. And then you need the name of the software. I know the name for R, it's r/base. So now I didn't write entirely R base, only R minus sign and BA. And then I can complete with the tab. If I press the tab, you see that it completes the name. But there might be more programs with the same completion. So press again the tab twice, and then it gives all the options. Okay. We don't need the others. We just need R base. Again, if you don't know how to install a software, you have to Google the instruction, okay? If I press enter now, Password. Good. I put my password. I think it is wrong, sorry. Let me type it again. Okay, and then it gives to you a list of everything is installing, and it says, I need 142 megabytes of archives. After this operation, 400 megabytes of additional disk space will be used. Do you want to continue? Yes. Let's give it some time. It has to download everything and install it. In my case, the PC is quite recent, and therefore it will be relatively quick. Okay. It's already finished. Yeah, minus base. After APT, you don't have a space. It's minus get. That's awesome. Okay, let me see. It seems that there is some problem with the connection. Okay, so you start with the machine or So you should install the virtual machine first, then it's but if it's not installed, it's not installed, it can install it last time. Can you be sure it's not? It should be. And last time it was a machine. We start, I don't understand what thing. So. And then we also the B that was here. Let me just check with Fernando. Fernando, does it work in your case?
I'm still trying to unlock this Linux because I have the virtual box, but to make the Linux, I'm still trying to install it. So I'm not in your step.
Okay, I see. So it is updating the list in the software. Okay, so I'm not sure what the problem is, but there is a problem with the connection with the network because it doesn't see the network outside. And with the browser, yes, but with the terminal, no. And I don't really understand what is the problem, and maybe a problem related to the Wi-Fi connection, but I'm not saying that, so I don't think. You could try to connect the PC to the phone and see if something changes, but I'm not really sure. And I don't really know what is the matter. So basically, all the three of you have this connection problem, and therefore let's move forward by you following me, and then I'll change the next topic in the lecture to avoid just to work myself without you having the possibility to follow me, okay? And what we could do, now let me just install I already installed it actually. So I clear the screen and basically take note. Now, let's clear the screen and let me start R. I just want to show you. It's working. Okay. It downloads. Okay. So we solved one connection problem by connecting with the phone. So probably there was a connection problem. I don't understand really what could be the reason because I am connected with the same Wi-Fi, but I'm not sure. Maybe that there is. It will take some time. And while it works, just follow me a little bit. Let me check. So the other arrow will be not a problem. Okay. Okay, so let's Okay, let's just wait because otherwise we don't do anything today. So, um, let me start R just to show you. And once that R is installed, and sooner or later we will install it, and I think this morning already, but let me explain. You have in Linux just to type capital R and you get it, okay? And this is the R console. I clear the screen. In the R console, you can make operations like 2 + 2, etc. Okay. Now, I want you to work with me and follow me. So let's get out from here. Let's get out from the terminal and let me get out from the virtual machine. And please do the same and go to Windows. Okay, perfect. Now, in Windows, open a browser, a Google. And Google, please, R project. Go to the first link, the R project for statistical computing. Go to download, CRAN. And then here you see a list of mirrors. Get one you like, Austria, for instance. And then you have here the opportunity to click on download R for Windows. You have to download only the base. Only base. And then here you get, you get here download R for Windows, 86 megabytes. Download it. It's an executable file. Once you downloaded it, double click over it in Windows and get all the default options. Yes, 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 and then it will install it. Unfortunately, I can't show you the installation under Windows, but I think that you should be able to succeed. I'm waiting for you to install it. Please give me an okay when the installation has been terminated. And meanwhile, don't look at my screen. Just 1 second, because I want to check whether. Okay. Are you okay? It's installing. It's working. Yeah, okay. Okay. And Fernando, did you succeed to install R under Windows?
Yes, I just completed the installment and I'm waiting for
Okay.
to launch
Very
it. I don't know.
Okay, very good. Just 1 second, don't start it. Second thing that I would like you to install, and let's go to Google. And I also need to install it. So look for RStudio. And then first link, RStudio Desktop. Accept cookies. We need to find the download, so just 1 second. Download and install R. No, R is already okay, sorry. And go down. R is already installed, so you don't have to click on download and install R, okay? Let's go down, and here you see the files that you need to download to install RStudio. So I guess that your case is Windows. It's quite a huge file. So just download it and install it. I install mine, and mine is this one. It's also huge. So let's see, because it didn't start. Okay. I am now installing it in my PC, and don't follow me. You just have to download it and double click on the installer. I need to make something different. Are you installing it, Super? It's already installed.
Yeah.
And RStudio as well?
No.
It's downloading, okay.
Less than 1.
Okay. Okay. One second that I need to. One thing that you can try later on to install R is this command, look at my screen, without any name for the package, okay? And it may work. Now let me check if I can install RStudio. So you are ready to launch RStudio, correct? Are you, it's already installed RStudio. Okay, very good. 1 second, I am also installing it. Okay, perfect. So now I can get out. Now let's start in your menu, RStudio. You should find it under applications, okay? I have to find it where it is. Let's start it. It should be a window like more or less like this one. Let me check. Yeah. It's down. Okay. Okay. I hope you could get here, Fernando. There is in the room one student got it, and the other one is downloading.
I installed the RStudio.
Yeah.
But I don't know if I can waste 1 or 2 minutes of your time sharing my screen.
Okay, so it means
Or I just let the other students, then after the class I can ask them.
okay, very good. Okay. Sorry? I didn't understand. Ah, okay, sorry. Let me see. No, it's only Fernando. Connected is only Fernando. Okay, Fernando, so basically you said that it's still downloading or installing?
No, I installed RStudio and I installed the R, normal R.
Okay, can you start RStudio? And you should find the icon of RStudio under the application of Windows. So
yes,
if you make...
Okay. Just open the message, check the message box.
Ah, okay.
I sent something now.
This is R, not RStudio. So
Okay.
I think you started R, but you should find
Okay.
also under Windows the icon of RStudio.
Okay, I'm launching now RStudio and I will send you a screenshot now.
Okay, good.
I send now.
Okay, this is perfect. This is RStudio. Good. So you are all set. Okay, let me just increase the font because it's this is really unreadable. So it should be under options. Let me see, plot session, to new sessions, start. No, it's not here. Let me see where are the preferences. I am looking for the preferences. Code, view, zoom in. Okay, good. Okay, I zoomed it because otherwise it's a bit. So what you see here is an environment for working in R called RStudio. It's very useful. And the environment is such that your screen is split into many sub-windows. And you can select what are the windows that you want to visualize. But here you have on the left the console. The console is waiting for your command. So let's concentrate on the console. On the right, there is a file manager, and there is also another environment that on the top, which shows what are the data that you uploaded. So let's forget about it for now. I just want to draw your attention that in these windows, you have several sub-windows. So for instance, if I look on the upper right, there is now active the environment, but I can also show the history. I can show the connection. I can show a tutorial, okay? And let me go back to the environment. In the lower one, the file manager can be replaced by a plot window, can be replaced by a window that shows the packages that you can install under R, the help, and the viewer, I never used it actually, and viewer and presentation, I never used it, so I'm not sure what is the purpose of these options, but we can forget about it. Let's keep the plots, okay? Because this is useful. And now let's concentrate on the console, because if we want to learn to use R, it's like the Linux console. We need to learn the commands. You see that there are also menus, but let's concentrate on the console because it's quicker. And then you can also explore the menus, because once that you learn to use the console, you can also use the menus. First of all, let me clear it. To clear the console, Control L at the same time, okay? So in the console, you can make calculations like 2 plus 2, it's 4, like 2 times 10, it's 20, okay? So usual calculations. And you can also raise a power, 2 to the power of 3, 8. But what if I want to compute the square root? Okay, the square root can be computed by doing like 16 to the power of 0.5, it's 4. But if I want to, for instance, compute the logarithm with base 10, what should I do? So I need to know the instruction, okay? So let me just show you what is the instruction. It's log 10, and then between parentheses, let's put 100. It's 2, okay? So what if you don't know the instruction? Okay, if you don't know the instruction into R, there is a very simple solution. The very simple solution is that you go to Google, and then you write here logarithm base 10 R project. First link is videos. Go to the first link, text or link. Log R documentation. You see R documentation, logarithm and exponentials, and you go here. And you see here, it's a bit tiny, okay? The list of the instructions. You can use log base equal to, and you put whatever you want, okay? So for instance, basing on this, I can make a cut and paste. Copy, and then I paste here in the console, paste. Of course, I have to substitute not X, but for instance, 100. And base, let me put 10. Oops, I forgot to close the parentheses. You see, when I forgot to close the parentheses, he tells me, you forgot something. Here is the parenthesis, and then I get the 2. Okay, so with Google, I got the help. There is another possibility. If you know the name of the function, you put a question mark and you put log. And look, RStudio. It tells me all the functions that start with log. I go down and I select log 10. So question mark log 10. And you get here, under the help, the same help that I got with Google. Nice. Good. Now, let me show you. I clear the screen. The power of this software, which is analogous to MATLAB. Let me show you the power. Let me perform today the same exercise that I did in Excel yesterday. I tried to compute the probability density distribution of generated data. You have a question, Fernando? No. Okay. And but let me compute it for not for 15 numbers. Let's compute it for more than that. Or let me do it first with 15 numbers so we can get a comparison with what we did in Excel. You remember that we took like 10 minutes to do that, okay? So first of all, let me generate with the Gaussian distribution the 15 numbers. So let me give a name of a variable, a vector. Let me call the vector of the generated data sim Gaussian. And you can choose whatever name you want, okay? Sim Gaussian is a bit too long, but we understand it. I know that to generate with the normal distribution, the instruction is rnorm, and then I need to open a parenthesis. Look at RStudio, it gives to me the help. rnorm, you have to give the number of data, 15, mean, and standard deviation. Let's give, look at the help, mean 0, standard deviation 1. What does this mean? It means that if you don't specify the mean and the standard deviation, the default is 0 and 1. So I can just press enter. And here is done my simulation. If you want to see the numbers, you just have to type sim and then tab Gaussian. No, sorry. Sim, and then in the help, select sim Gaussian. Return, and you get the 15 numbers. Okay, good. Now, how to compute the probability density? Very easy. Of course, you need to know the instructions. It's first of all, let me.
Professor,
Yeah.
I did not. I did sim Gaussian equal to R norm 15 as you did, and then I put sim Gaussian, but I didn't get this output. For maybe it's because I didn't clear the tab as you did. What is the command to clear everything?
To clear the screen is Control L. I don't think this is the reason, but try to make it again and follow me. I clear the screen, okay?
Yes.
And then push on the arrow up and you get back the previous instructions. So,
yes.
Okay, so make the simulation again. Do you get any error?
Sim Gaussian. Okay, I got the numbers now.
Okay, very good. I clear the screen. So let me compute the density. Let me plot it. Plot density, sim Gaussian. And you see in the plot window, we got the density. It's done. So what we did yesterday, we just did in 10 seconds. Now, let me repeat, not with 15, but with 10,000, okay? So, arrow up, I get back to the instruction of the simulation, but instead of 15, I put 10,000. And then plot density, sim Gaussian, arrow up, and you see that now it becomes a nice Gaussian distribution. It's symmetric, it's everything is indeed Gaussian. And you may still say, but yeah, it's not perfect. It's not a perfect Gaussian. So don't do that because you need some computational capacity. But now I put 2 more 0. So I am at, let me put it at 10 millions. Now it's a perfect Gaussian, okay? So this is just a demonstration of what you can do with, I mean, it's really powerful. And now to complicate things, let me just think of it. Because you may say something like, yeah, but can I trust these functions, like density? Is it correct? I want to check it. Okay. Let's try to manually, like we did with Excel yesterday, to compute the density. Why I'm doing this? Because now we are learning by doing, so try to understand what you are doing, and now you learned how to simulate with a Gaussian distribution. The instruction is R norm. The instruction is density. You learned how to make a plot because it's just enough that you put plot, use the function plot. Now, in computing the density manually, you learn more things, okay? I just wanted to let you know one other, to point your attention to one other thing. In the environment, in the upper right window, now you see listed that you defined a vector, large numeric, 10,000 elements. It takes 80 megabytes. So this means that you memorized in R this vector, and it is there. Of course, it is there. It is kept also for your next session, provided you save when you go out. And you can save, for instance, here, file in RStudio, you can save it. Save all, okay? I can save it. I'm not saving because I don't want to save a vector of 80 megabytes, okay? But you can save it. And if you go out from RStudio, it asks you if there are unsaved things. Would you like to save? So if you save, you find it somewhere else. And you can also manually define variables, like you can write a equal to, and then you see that A appears in the window up there with the number 2. And you can also use the variable to make computation, like A times 2, it becomes 4. Let me remove A because I don't need it. RM, remove A. Okay. So just learn it. Now let's compute the density. But let me generate a shorter series because it's too, I mean, 10 millions is too demanding, okay? And it becomes very slow. And you can follow me, just simulate 1000 data, okay? Sim Gaussian, Ernorm 1000. And let's have a look at the density just by calling again plot density. And you see it's not perfect, but okay, that's fine. Okay, let's try to compute, let's forget about the density computed in this way, and let's try to compute the density on manually. Okay, let me clear the screen. What we did yesterday is to divide the range in many subparts. First of all, what is the range of the simulated data? Let's see, min, sim Gaussian. The minimum is minus 278. And what is the max? Max, oops, sim Gaussian. 292. Okay, let's go from minus 3 to 3, okay, to compute the density. And it's, let's divide this interval in 50 sub-intervals. Let me think how to do that. Okay. So let me, from -3 to 3, and if I go with steps of 0.1 is 60 intervals. Okay, let's go with steps of 0.1 from -3 to 3. So my objective is, let me plot the simulated time series, plot sim Gaussian. It's here, you see on the right, and it's plotted with points. And so my objective is within each one of the steps from -3 to 3, and any step has a width of 0.1, I want to count how many points are inside the step. So how many points here in the plot are between -3 to -2.9, and then second step, how many points between -2.9 to -2.8. Okay, good. Let me make this count. I need to make this computation 60 times because I have 60 steps. Okay, so I need a cycle. You know that within codes, essential elements are cycles and conditions. So how to make a cycle in R? Okay, this is the instruction. For, and then you need a cycle variable. Let's use I in 1.60. This means I want to start a cycle. I'm telling R I want to start a cycle, and then if I press enter, R says, okay, give me instruction of the cycle. Given that it's more than one, I need to open a curly bracket because, I mean, I could write here for 60 times, just print or no, sorry, cut. Cut means print on the screen, okay? I could say, okay, cut sim Gaussian I. Be careful, I between square bracket means go to the vector sim Gaussian and take the element I and print it on the screen. And after you printed it, start a new line, fill equal true. So now I am expecting that it plots, it's just one instruction. So I don't need any curly bracket. I am expecting that it plots the first 60 elements. And this is what happened. But now I want to do something more complicated, more than one instruction. So I need to tell R, look, I have several instructions. Your question. Yes. True. Fill means fill the line. Fill the line is true. Okay. Okay. Because if I don't put this command, so I went back with arrow up. Okay, cycle again, arrow up. I don't put this command. It doesn't start a new line after printing the data. Okay. Now it's more complicated because I have in the cycle more than one instruction. Let me clear the screen and let me start again the cycle. Now I need a curly bracket because if I have in a cycle more than one instruction, I need to use curly brackets. One curly bracket to open the cycle and one curly bracket to close it. Now there is the big challenge, how to get a curly bracket in your keyboard. So it depends on the keyboard that you have. So in my case, but I'm not sure it is also your case, it's right Alt plus number 7, and I get two curly brackets. Okay, and oops, sorry, I didn't give any instructions, so Okay. Did you find the curly bracket? Okay. Now let me give the instructions. And the first instruction is I forgot to define a vector first. So let me go back 1 second and let's define a vector called dense. We can this vector will contain the density, the 60 density, 60 because I am computing the density in 60 subintervals. So let me define dense equal repetition 060. It means I define a vector which is a vector of 60 zeros. And remember this, in R, when you want to use a vector, you need to predefine it first. Because now that I predefined it, I can also visualize dense in the first position. If I didn't do that, like now I want to define, to visualize a vector in the first position of a vector that is not defined, it says not found. Okay. Now I can try again.
For me, even the dense is not found.
Because you didn't define it. So you have to repeat this. Dense rep 060.
Okay, I put dense C. Okay. With
Okay.
I in the end. Okay, thank you.
Yeah, no problem. Now let's start again the cycle. The curly brackets. Okay. Now let me write dense I, and now I have to compute the density. So, question, how many elements of sim Gaussian are between -3 and -2.1? I repeat the question. How many elements of sim Gaussian are included in the range -3, -2.9? I have to compute this number. And then I need to divide the number by the total size of sim Gaussian, compute the frequency, and then I have to divide by 0.1, which is the dx, to compute the density. Okay, so let's compute the number of sim Gaussian elements. I am just repeating it. Let's compute the number of sim Gaussian elements in the range -3, -2.1. Good. Let me write the function. Of course, I know it. Length, open the parentheses, sim Gaussian. The length of sim Gaussian, if I close this here, gives to me the total size. Now I have to tell it that I only want the size of the vector in the range -3, -2.1. Good. Okay, so in order to make this specification, I need to open a square bracket. And then I say sim Gaussian greater than -3, sim Gaussian greater than, let me open a square parenthesis and you will understand why, -3, but in the first round is -3. In the second round, it must become -2.9. Okay, so let me write -3 plus E minus 1 times 0.1. Do you see that in the second step, it will become minus 2.9? Because in the second step, E will be equal to 2. So in the second step, it will become minus 3 plus 2 minus 1, 1 times 0.1. Okay? Yeah?
I have no shell creator.
The symbol, yeah, should be, I have it in my keyboard, but okay, found it.
Yes.
Okay, but now I have to give another condition. And the other condition is that lower than minus 2.9. Okay, so the second condition, two of these symbols. Let me put a space. I don't remember whether I have to put only one commercial E or two commercial E. Let's try with two, okay? And then if it is a mistake, I will recall back the instructions and correct it, okay? So now the second condition is sim Gaussian lower than minus 3 plus E times 0.1. It should work, but now I have to divide this length divided by the total length of sim Gaussian. Okay. And I have to divide it by 0.1. Okay, let's try to press enter and see what happens. Maybe that I made some mistake. Okay, let's see. Okay, you see that there is length. There is something wrong. So let me just get back it. Okay, and let's see what is the problem. And sim Gaussian, sim Gaussian lower than logical one. Okay, let me try to put only a commercial E because this may be the mistake. Okay, let's try. Oh, great, no errors. No errors. Before plotting it, let me make this verification. You remember the integral must be equal to 1. Let's try. Sum. Sum means summation. Dense times 0.1. Let's see. There is something wrong here. So sum dense is 1. Is it correct? Let me see. Oh, yeah. I don't have to. Yeah, I think it is correct. Let's see. Okay, I think it is correct because it's the integral is only the sum. Or not. Okay, let me check in another by making the plot. Okay, first of all, let's try to plot it. Plot dense. Okay. Plot dense. I should give actually Let me try to do this because, okay, let's try with plot dense first of all, and let's see what happens. I think it is reliable, but you see that the index is not correct because the index is should be from -3 to 3. Okay, so let's correct this. So in order to solve this, I need to give coordinates for x and y. So let me give the x sec from -3 means sequence to 3 steps 0.1. Let me see if it works. No, because yeah, I understand. And let me do like this, 2.9. Okay, now it's correct. And I gave a sequence for the horizontal axis. I gave a sequence of numbers from -3 to 2.9 with steps of 0.1. Let me just show you what happens. If I just put the sequence, you see the result of this instruction. You see -3, -2.1, -2.8 is what I want. And actually, it's fine. Now, let me make a comparison because we still don't know if the density was well computed. I mean, the shape is fine. But first of all, let me plot the graph as a line. Okay. And type equal line. Okay, now it's plotted as a line. So in order to check if it is correct, let me try to compare with the density. And the density, let's look at the order of magnitude. It should vary from 0 to something like 0.03. Okay, let's see. Plot density, sim Gaussian. Actually, you see that there is something wrong because indeed, let me think if there is something wrong. Indeed, yeah, there is something wrong because there is an order of magnitude of difference. So my density is lower. So what is the reason? Let me just check. The computation. I get back to the cycle. Okay, and let me repeat it. Okay, let me see. I divided. Yeah, sorry. This this was a mistake. I should have divided here. I should have divided here. And I think it makes a difference. Let's see. Yeah, now it's correct. Do you understand what was the problem? Let me go back. Okay, let me go back to the erroneous instruction. You know, here I wanted to divide by 0.1, which is the length of the step. But actually, I divided by 0.1 the length of the vector. So this has to be placed outside the parentheses. Now it is correct. And there is one thing that you may ask me before we make the break. And the one thing is, let me clear the console. The one thing is, let me start from this graph. It is very fragmented, you know, it's not very smooth. If I plot the density with R, why it is smooth? It is smooth because R smooths it. So in the computation of the density, R basically smooth the result because it's more physically reliable. Okay, so what is the take that you should have from this? Because The take that you should get from this experience, first of all, we started with R, and now you know how to use it. We still don't know how to use it under Linux because we had some problem. But in any case, now you know the package, you understand what is the advantage that it can give to you. We are not going much further because now I want also to introduce Python. We only have one more lecture with me to complete these lab experiments. So I'm not going much further. Okay. Today in the afternoon we will still make some exercise with R, but not much further. What is important to me is that you got an idea, and if you want to explore this idea, now you have the means to do that. And I also will try to solve your problems with the virtual machines, so you can also try to make the same computation if needed in Linux. You have the means to do that, the knowledge. You will not have the need for the exam to specifically learn much more on this. For the exam, I would like to propose to you something like you present something, for instance, let's suppose that you are interested in R, and then I may ask you, prepare a code for computing in R, the return period of a given time series, present the code, present the ideas, give me a presentation, that's fine. I mean, the exam will not be like question and answer. It's like, so you don't strictly need to get a deep knowledge of what we discuss, all of what we discuss. You may make a selection. I understand that I'm giving a lot of information and in very few hours, and therefore you cannot really get everything of it in an expert mode. But it's important that you get and you don't forget what are the bases, what are the means in order to better respect it. Because what I would like to do more than that is also to explore Python and to make also some practical computation, and probably with Ray, the next teacher, you will have the opportunity to do that. But he may use Python, may use MATLAB, so you have the means to, sorry, not MATLAB, R, you have the means to follow him. Okay, good. We took 10 minutes more, so let's start at 2:10, okay? Because otherwise the break becomes too short, okay? So see you at 2:10, and Fernando, do you have any question? Everything is clear? Okay.
I prefer to. I did this, but I get error, so I will have to revise afterwards.
Okay, try to do one thing if you have a little bit of time. Put screenshots of your error in the chat, and then when we meet back, I'll have a look at the chat and we can discuss. Okay?
Okay, I'm putting all the errors that I got on the chat box now.
Very good. Okay, see you later. Let's start at 2:10. Thanks a lot.
Okay, thank you. Ciao.
Ciao.